Nice to see you all, guys. So I'm gonna tell you how we on IT side keep ourselves calm while in the call centers we have some operational chaos. And before I continue further on, a little bit of disclaimer. I'm gonna just share our journey, our path, how we implemented monitoring for our solution. It's not obviously, it will not be the best setup. I'm not claiming the best setup. I'm not claiming the best approach that we used, the best approaches. So yeah. Now back to the figures, back to the numbers. We have around, actually more than 4,500 of agents in actually 20 call center locations. Out of those 25 global offices, as well as we have a lot of remote agents as well. Actually, currently it's around 40% of those agents are remotely working from actually worldwide, right? Those agents are doing about on average 8 million calls a month. That's on average. And our main market is United States. So that means that the, let's say, working hours of the agents by our time is from 6 p.m. until around 6 a.m., right? So it's the evening and the night, right? So if something happens with the call center system, usually we get called at the evening, at the night, and we need to fix those problems, right away. Now, when we're speaking about call centers, we're speaking about VoIP, so voice over IP. It's a bunch of protocols and RFC methods that no one really obeys, at least to 100%. Each implementation can differ in service provider level, right? We deal with media streams, we deal with proxies. We need to know actually networking a lot. And most of the traffic in VoIP is actually transmitted using UDP. Quick question, what's the difference, TCP, UDP? Well, actually, in UDP, you don't care. You send the data, you don't care if it was delivered or not. It's much faster than TCP in that regard. So, yeah. I like this quote. I'm going to just read it loud. If builders build buildings the way programmers wrote programs, then the first woodpecker that came along would destroy civilization, right? Well, it's exaggerated, but actually it describes our situation quite accurately. Now, right now, I will need a little bit of your help and a little bit of your imagination, because imagine that this is a black box. Imagine this is a black box, right? It's not really black, but imagine it is. It was supposed to be, at least. Now, this is how I would just, draw how our system looked like in 2020, right? System, nobody actually knows what it does, how it works. I mean, we know what it does, but nobody actually knows how it works, right? And the more actually you dive in it, the bigger the black box actually is. It's written in PHP, and don't tell anyone. Perl, Bash. So it has a lot of unclear flows under it. Literally no documentation at all. Literally. So you have to collect that documentation yourself. We had weekly incidents. We actually counted days without incidents, to be honest, right? Obviously questionable architectural solutions, and we had some software part, let's say, hosted in AWS, and we had some part also hosted in each office location, so-called proxies, but they were also, let's say, self-developed, right? And any change that we do actually provide us unpredictable results. So any change that we do in production or we do a release, basically everything can break at any moment, right? So quite a, let's say, intransparent system, right? when we're getting back to VoIP, so what kind of potential issues can we face in VoIP applications? So we can have some network issues like, let's say, packet loss, high jitter, or low bandwidth, which will directly impact your call quality. We can have third-party issues. By this, I mean any issues that are related to the VoIP carriers. So if they have any issue, then your calls will also suffer. User-side issues, by that I mean that user can have some local issues with his audio devices, I don't know, microphone, and etc. So that will definitely cause issue, at least for the locally for the user. And any actually performance bottlenecks on the software or hardware will also directly impact the call quality. On top of all of that, all of those potential issues, we have basically self-written everything around media and around calls. So event-driven actions, call control mechanisms, stats calculation, dispatching the calls to other systems, and etc. So that causes additional potential issues, right? And when someone at that point, when someone kind of reported us issues, the main probably, let's say, the main recommendation that we did is to restart the application or restart some parts one by one, and let's see that if it fixes the issues, right? And in majority cases it did, right? But okay, if restart works, what problem are we trying to solve with monitoring, right? Well, maybe we're sick of getting calls in the evenings, right? Maybe we want to have some rest and then party in the weekend because, we're kind of IT people. We want peace, right? Well, if seriously we want to add the transparency on how the system works, we want to understand why those outages and performance bottlenecks happen and where specifically. Well, because any outage or issue that impacts the business operations actually costs us money. So nobody really is happy, nor the IT people who is getting called every day, every night, right? Nor the business stakeholders that actually lose money because of that. That's why we need for proactive issue detection instead of reactive firefighting. And obviously, if you're firefighting all the time, you don't have any, you don't have any time for anything else, like R&D or improving the solution, right? Now, if we're talking about application performance metrics, and let's say, my presentation is about application performance metrics mostly, right? Where do we start? What we want to monitor, what we need to monitor. Now, there are actually like several methods. You can think about the use cases of your application, and you can kind of try to cover with monitoring the use cases, each step of the use case through which your user is going through. You can take the most frequent problems that are happening if you have a record. If you know the system quite well, you can also identify some potential critical failure points, like single points of failure, etc. In case you don't know, there's always methodologies like red, use, and 4 golden signals. I will not cover them right now. If you want to discuss them, you are free to catch me up after the presentation. So in our case, we started with something simple. We started with call post-processing. That's basically a process where the call, after it's ended, it gets to the statistics, it gets dispatched to several systems, and which is actually very important for the business logic and etc. Now, when we know what we want to monitor, the next question comes about the tech implementation. Now, at that time, we already had Grafana and Prometheus stack, so it was a no-brainer for us to use it, right? But we actually didn't use the Prometheus PHP library, and for several reasons. In the Prometheus PHP library, actually it's unofficial, although it's stated in the Prometheus website, it's unofficial, and it requires you to use, first of all, Redis to store the metrics, And if I'm not mistaken, you have to come up with your own data structure in Redis for those metrics. But we needed a plug-and-play solution, basically, to not make things more complex. So we started to actually use StatsD libraries. StatsD is basically a format for metrics, which is an alternative to Prometheus format. And we used StatsD exporter, which is provided by the Prometheus developers themselves. And basically what it does, it just transforms from one format to another. Now it's a separate, basically it's a separate entity, separate service, where your application basically sends the data in. And then it exposes to the metrics via HTTP/metrics endpoint, usual endpoint, which is then pulled by the Prometheus, right? Now, so on the application side, basically what we need to implement is we just need to import the library, and we need to define the endpoint of StatsD exporter. And every metric that we're gonna, and then we need to also put where we want the metrics in the application, right? And then the metric will send directly to StatsD exporter via UDP protocol. Now, there is another method how we can do this is via Prometheus push gateway. Why not that way, right? Well, because Prometheus push gateway actually, well, it kind of does the same. So you can replace this one by the Prometheus push gateway. But the difference is that you get the data via HTTP, via TCP. So in case your Prometheus push gateway hangs, your actual request to those metrics also hang, and that can also hang you parts of your application. So we're using UDP here probably because because we are in VoIP, right? But that actually guarantees that the application doesn't care if the metrics are received, right? So if StatsD exporter goes down, we don't care. It doesn't impact the application at all. Now, we get the numbers to Prometheus. We get something like this, right? We get some numbers, some digits, some quantiles, some counters, etc. What do we do with them? Now, the next obvious step is to create some graphs in Grafana. We created them. The first impression was like, wow, like graphs. The next question is, what do we do with them? What do we do with those values, right? Lots of graphs, I don't know, errors, error graph, execution time, and etc., etc. What do we do with them? Now, you need to understand. You need to understand those values. Basically, you need to identify what's normal for your application, right? And specifically, when we're talking about legacy application, it can behave differently from what you think, right? You can have, obviously, you can have some best practices when of execution times, etc., and it can, the legacy application can behave differently, right? So you need to identify the normal. You need to identify the patterns. You do that basically by looking at your metrics throughout the day, throughout the week, throughout the night, throughout the month, right? And then you can understand how your application actually works. And that is needed to actually configure first alerts. Your metrics are quite, well, they may be not 100% useless, but with alerts, they are more useful than not, right? So you need to configure your first alert. You can do that in two ways. You can identify that pattern. You can identify the normal values for your application, and then you can try to set the thresholds to be higher or lower than those patterns, and then hope for the best, right? Hope for the best that the issues will be catched by those alerts. Or in our case, we didn't need to wait long for next issues to appear. We already had metrics, so when the let's say usual issues appeared, we could go back to the metrics and see what's happening there. See if some fluctuations happened, can identify which metrics can be used for the alerts and set the alerts there. Obviously, together with some internal application performance monitoring, we need also to monitor third parties. As I mentioned previously, we are dependent on third parties, on third-party carriers, for example, third-party web providers, right? Which can also impact the call quality. And we also do, call metadata sending to other systems, internal systems, as well as external. So we need to not only monitor the availability. Availability, of course, is the number, let's say, first thing that you need to monitor, but we need to also monitor, let's say, the quality. If we're speaking about the web providers, we need to monitor the quality of the provider, whether our calls are not failing or the trend of the answer rates is on the same level as it was like previously, 7 days ago or a month ago, right? And if with the internal system call dispatching, we can quite easily solve the issue by adding our own metrics. With VoIP, with VoIP-related metrics, it becomes a little bit different. But for that, we just found a ready-to-use solution, open source solution, which is called Homer, Homer SIP Capture. Basically, well, they say that it's a VoIP debugging monitoring tool, etc. But actually, it's a trace collector. What it does, it collects traces from your VoIP applications, VoIP nodes, VoIP infrastructure. You can relate to it, for example, for HTTP requests, you have Jagger. Who knows what Jagger is? Okay, someone knows. That's good. So Jagger basically collects traces from your services, and you can see how the HTTP request flows throughout your services. So you can identify the bottlenecks. You can see the execution times of each, internal service call. So you can identify the bottlenecks and then take a deep dive into the logs. Homer basically does the same, but for VoIP. You can see how the call goes throughout your application, throughout your infrastructure. You can see, of course, the execution times. You can open each message, see its details, etc., etc. But actually, what is more useful for us is that it exposes ready-to-use metrics for us. So it exposes the metrics which we can use, and those metrics tell us about the request rates, the responses that we get from different carriers, so we can configure the alerts accordingly, right? After configuring the alerts, obviously, we will need to revisit them time to time. We will actually need to revisit them continuously, because some of them will not hit the thresholds. Some of them will not be useful at all. Some of them will have lots of false positives. You will have quite a high alert noise, right? So you will need to revisit those alerts, optimize those thresholds. You will need to find the best threshold that suits for you. And what we also did, we split those alerts by severity. So we have, let's say, normal severity, which kind of causes alerts and notifications to our development teams so that they can identify the issue. The normal, hitting the normal threshold doesn't mean that there is an impact to business operations, but there's definitely something wrong. So we can go and, find what's wrong there, right? And then we had critical thresholds, which we configured, which basically means that there is 100% impact for business operations, right? And that it's a critical issue. It has to be investigated right now. And for that, for those alerts, we actually send them to our dedicated incident management team directly, so that they can escalate the process accordingly, especially if it happens in the evening or in the night, right? In your case, that could be a dedicated monitoring team or a network operations center. By the way, the incident management process at that point of time was also kind of in the development process, because it was kind of new process to the company. So we kind of developed both monitoring and incident management process in parallel. And obviously, your alerts will not catch some of the incidents that will certainly happen. That's okay, that's fine, that's totally fine. You just need to check, like, if you have existing metrics that show some fluctuations, where you can cover with some new alerts, or maybe you need to add new metrics if you don't see anywhere the issue, right? When speaking about adding new metrics, the key here is to do a root cause analysis on a hot trail. That's, I would like to emphasize, on a hot trail. Otherwise, your engineers who were working on the incident will basically forget the details. So you need to have the most details, so that you need to understand which part of the application is faulty, which you need to cover with those new metrics, right? And okay, let's say we got the server-side monitoring. But what about client side, right? We're still having agents calling us, telling, okay, something doesn't work, right? And we're gonna tell them, okay, you need to restart your PC, your phone, right? At that point, we didn't have a unified solutions for our call center agents. So in some offices they were using like hardware IP phones, the old ones. Somewhere they were using open source software, but at some point we decided to unify this, and we developed our own web client based on WebRTC stack. So WebRTC stack, just in a few words, it's a browser stack to provide real-time communications, both audio and video. So basically everything on the browser that uses audio or video works via WebRTC, like Teams or Zoom, whatever. And I knew at that point that there were some ready-to-use platforms for this WebRTC client monitoring, right? One of them was CallStats, which we actually tried and used for some time, but at some point it was acquired by a different company and the project was closed. Then we started to investigate towards PeerMetrics.io, which is a similar solution, but it's more oriented for video conferencing. And at some point, the project was closed too. By the way, recently they've open sourced the code for that project, so if anyone interested, you can check. And then the third solution which we investigated was WatchRTC. They have a whole, let's say, whole set of applications to monitor your WebRTC application, different stages of your application, right? But for us, it was quite expensive. So we decided that we're gonna build our own. How are we gonna build it? WebRTC actually has GetStats endpoint where you can get some quite useful information, like again, some network stats, jitter, packet loss during live call. So you can pull that API during a live call. You can get actual data for that period of time. What you can see here is already parsed data, which is being actually used by us, and it's also enriched with some additional information like geolocation, geohash, and as well as other additional information. What actually you can one of the useful data that you can get from WebRTC stats is actually the network type of the user, if he's sitting on Wi-Fi or Ethernet or he's using VPN. So even that is detected by the WebRTC stack. Now, and also we included calculated values for two fields, which is MOS and R factor. So MOS is basically a standard way in VoIP to evaluate call quality. You can check the formula. I will not really dive deep into it, but basically on the network, based on the network stats, it gives you a rating for the call quality. Now, okay, we get this data from the call, from a live call, right? We get that data with some intervals, right? Where do we store that data? How do we actually display that data? We decided to use Elasticsearch for this purpose, and we started to send this data to Elasticsearch. So basically at this moment we are triggering this endpoint each 2 or 4 seconds. We're getting the data, we're sending it to Elasticsearch. And then in Elasticsearch, we were able to build some cool graphs, cool dashboards, which would show us some general information as well as call-specific information. So we could see how let's say the network metrics change throughout the call, how the audio levels change, how other things are changing throughout the call, right? And moreover, we were able to draw some maps. Obviously, the first thing that you want to know is geography of your users, right? But also the other thing, which is more important, is the average call quality. So we utilized that MOS metric, and we drew a map of the average call quality in different regions, and that actually helps us to understand what is the call quality across different regions, and lets us understand if we need to expand into specific region in terms of infrastructure or not, right? Now, if we're talking about the condition now, so and if we're talking about specifically application performance metrics, so currently in only the call center VoIP project, we have around 493 application metrics. Out of them, 216 are our customly made metrics. The other ones are either used, exposed by some exporters or some open source applications, right? We have 32 dashboards and 55 alert rules, which are, again, only from the application side. We're not talking about the infrastructure point of view. And we kind of made our black box a little bit more transparent, right? Now, the benefits that the monitoring provided us is actually that you don't need to be in management to make data-driven decisions. Data-driven decisions should be also done by development teams, by developers, right? Example, developer is doing some optimization for the application, right? How can he see the change without actually the metrics, right? So he does the change, he sees how this impacts the production application specifically, right? Also, monitoring allows us to detect issues after we deploy something. Obviously, we don't wait for the user reports. We deploy and we check the metrics right away. So if something happens, we can see it right away, right? Third point, yeah, you can debug issues easier if something happens by its own. And it allows you to see a bigger picture of the application, whether independently, if you're a developer or IT operations or site reliability engineer. If you work on the infrastructure for that application, you can see how the application performs and how your change, for example, infrastructure change, actually impacts the application flows, right? Now, the takeaways is that don't be afraid of legacy systems. Don't be afraid of black boxes. You can actually make them a little bit more transparent with monitoring. If you don't know where to start with your application metrics, you can identify the most critical weak points in your system based on some statistics if you have, or you can follow actually the methodologies, right? Now, the hardest part, which I didn't really even cover it in the presentation, but actually the hardest part is to convince people why actually monitoring is needed. I mean, convince developers. Because, we're used to monitoring on the infrastructure side, right? We're used to that. But usually developers are not really keen to implement application performance metrics. At least that's my experience, right? And you don't need to, build your custom metrics. You don't need to, for every use case, right? You can use some ready-to-use exporters or third-party solutions. For example, if you're using Redis, right, you don't need, on Redis side, you can set up the Redis exporter. You can check the Redis queue. So, for example, right, Redis messages. So you don't need to cover that part in your application. So you don't need to really waste time on it, right? And just remember that after some time, if you're building your system and you're not really covering it with proper documentation, proper monitoring, it will eventually become a black box. So my advice is to ship the applications together with monitoring right from start. Yeah, that's it. Thank you. Time for questions.
So the question: are you planning to use Elastic machine learning engine or not for that for anomaly detection?
Not for now. We're not using any anomaly detection, but that's something I would like to, try out. Didn't have time to do it until now.
Thanks.
I can add here that regarding machine learning for anomaly detection in different kind of metrics and even in application logs. As I said, so we have data science team, and this task is in their backlog. This task to find anomaly in application logs is not solved. We did research already. There are some solutions which advertise that they solve the problem, and they have solution which will find anomalies in your log, but it's not true. Even Elastic itself, the company, we have direct contacts with them. They have Elastic machine learning. We tested their solutions with our logs, and their engineers finally admitted that their solution is not ready yet. So we will continue research and development in this direction, but unfortunately don't have solution right now.
Yeah, thank you.
Thank you. Quick question. What are you doing with alerts? Are you just sending them, or are you have some like proper scripts that run, like as you're saying, restarts when the alerts happens?
We don't run automatic restarts scripts. Okay, we don't do restarts at all right now.
Okay.
We went away from that. So we are actually using MS Teams channels for getting the notifications. For critical notifications, we are sending to a dedicated incident management response email, which transforms into Jira ticket, and there is another process which actually does the escalation part. But yeah, when speaking about development teams, we're using MS Teams channels.
Okay. Thank you.
Okay, thank you for interesting story. I have a couple questions. First, maybe I lost something, but what was impact to business? Did you measure it? Really impact, like how convinced business for such complex solution, such complex metric as I saw. And second question, how you did audit your measuring system and metric system like that? Audit, I mean that your how to say it, your okay, your measuring is right for business, for flow business. It's a real bring on table well impact like that.
Okay.
Thank you.
Did I understand the first question correctly? How did we convince business?
Yeah. How we convince business? Yeah, because it's a hard. I am sorry. I am dying for monitoring. Really, I'm stay for that. But it's a first step. It's more harder than any.
Okay. The answer is quite simple. Again, as I mentioned, any outage of call center system causes direct business impact in terms of losing money. So, by doing some simple math, you get the time for implementing the monitoring and improving the.
Okay. Did you have numbers for convince?
We didn't have exact numbers at that point, but I mean, we had weekly incidents, so you understand what that means, right?
Yeah, I understand.
So yeah. Regarding for second part of your question about the audit, so we are speaking mostly about technical metrics, right? So we are speaking about technical metrics, right? And we are monitoring technical metrics. We're not speaking about, let's say, business metrics. They have their metrics of their own, right? And they can see how it, they can see the sales and etc. etc.
Okay, I can explain. For example, we have a metric like quality of call. Yeah, involved QA for example, team to audit how really you measure quality call. That what means your numbers?
So basically, if those numbers are true.
Yeah.
Yeah. Okay. We did test before actually implementing it, and actually, you are right in that part that you need to check the metrics if they are actually telling the truth. Because just a side note, right? That MOS metric, right? Before WebRTC, we checked with WebRTC. It actually works properly, and actually, in all the cases that we've detected and where we've analyzed the calls, the metric was true. But actually, before that, like MOS is not related to WebRTC. MOS is just a general idea how you can evaluate the call quality, right? And before that, when we had different solutions, the different client-side solutions, right? All of those client-side solutions have their own. They actually, some of those solutions, they provide so-called. Well, I don't really want to dive deep, but okay, let's go. They provide kind of so-called RTCP reports, which report you about like traffic that they've received, traffic that they've sent, and you can basically you can use that MOS. You can calculate that MOS even with some other party, open source or whatever solutions, right? But those solutions have different implementations of those reports. So, and what we've experienced is actually what you said, that those metrics are not true, right? But so yeah, we already knew that we need to check this. So we actually tested those metrics by our own, without actually after migrating to this WebRTC stack.
Okay, thank you. Who's next?
Yeah, one quick question. Do you know, like, when you call somebody on Zoom, WhatsApp, whatever, at the end of the call, there is often a question like, how was your experience? Did you ever do those, like, user experience, subjective metric collection and compare them to the technical metrics that you have received?
We actually did this. We did that for a limited time. Why we did that for a limited time? Because together with, let's say, objective feedback, we also got subjective and a lot of nonsense coming to us. So, we launched that feature. We had to actually disable it after some time. But we checked for some time, we monitored and we checked, we compared the subjective, let's say, opinion versus the metrics, Yeah.
So have you measured how your sleep has improved?
Yeah, that
After
part,
you
to be honest, well, I have metrics now about the sleep, but I didn't have them previously.
Are they, how much improved your sleep, like percentage something?
Yeah, unfortunately, I haven't tracked. I missed out that point.
Hello. Previously, you said there was some pushback from the developers.
Can you repeat again?
Previously, you said with implementing metrics that there's some pushback from the developer side.
Yeah.
What's the developer pushback like? Because it's more data. Oh, boo, more data. That's that bad?
Well, the usual questions that you get: why it's needed? What do we do with that? Well, like even after we've implemented it, it's not really being used as on purpose, right? So there is a kind of learning curve that you need to just go through.
Okay, sure.
And actually, for me, it also was, I didn't have any, I didn't have any experience with application performance metrics previously. So for me, that was also a learning curve.
I see. Thanks.
Thank you.
Okay, I'm kind of, if you have some more questions, then come in person and ask in person. Thank you, Promised Chocolate and Bandanas.